Venkatesh, and today I'm going to teach math on behalf of the Sai Education for Competitive Examinations. We're going to look at the boat and stream problems. It's a very simple topic, and once you get the idea, you'll be able to solve a lot of problems in this area. So let's get started. Alright, so let us look at the problems regarding boat and stream. Okay, the first question. A man can row a boat. It is row a boat, not raw. It is a typo there. So it is row a boat at 12 kilometers per hour with the stream. That is 12 kilometers per hour is the speed, and 8 kilometers per hour against the stream. Find his speed in still water. Okay. Now, another way of saying 12 kilometers per hour with the stream is 12 kilometers per hour upstream. Sorry, I beg your pardon, it is 12 kilometers per hour downstream, that is with the stream. And 8 kilometers per hour against the stream, another way of saying that is 8 kilometers per hour upstream. That means you're going against the stream, right? So if we assume that the stream is flowing downwards, when you're going with the stream, we will say 12 kilometers per hour downstream and 8 kilometers per hour upstream, that is against the stream. Just keep these terminologies in mind because they have different ways of asking the same question. Okay, now find his speed in still water. Now, the formula for still water speed is A plus B divided by 2. What is A plus B? A is the downstream speed, that is with the stream speed of 12 kilometers per hour, and B is the upstream speed, that is 8 kilometers per hour. So we take an average of the two, which is 12 plus 8 divided by 2, which is 20 divided by 2, which is 10 kilometers per hour. Always make sure that the units of both the speeds are the same. If they are not same, you have to convert it and make sure that the units are the same for both. All right. Next, you have to memorize these formulae and also try to understand them. Okay, we'll talk about it as we go ahead. Okay, moving on to the next question. A man can row a boat, again this is a typo, at 12 kilometers per hour with the stream, that is downstream. Find his speed against the stream, that is find his speed upstream if the current of the stream is 2 kilometers per hour. Okay, now the formula for this is this. Against the current, meaning upstream is equal to downstream speed. Upstream speed is equal to downstream speed minus current times 2. So when you fill in, you will get it as equal to 12, which is the downstream speed minus current. What is current? Current is 2. 2 times 2 is 2 is 2 times 2 is 4. So 12 minus 4 is equal to 8 kilometers per hour, which is the upstream speed. You have to memorize certain formulae. Okay, you will understand this as you practice more and more, but some formulae you have to memorize. Okay, now let's look at the third example. A man can row a boat, again it is row a boat at 12 kilometers per hour with the stream, that is downstream, and 8 kilometers per hour against the stream, that is upstream. Find the speed of the stream. All right, now you know this, here we learned a formula, right? Upstream speed is equal to downstream speed minus the current of the stream times 2. Now in this example, they have given you the downstream speed, they have given you the upstream speed, and now they're asking you to find the current. So just rearrange this formula and you will see that you'll get the current equal to 2 kilometers per hour. Okay, now a man can row a boat 10 kilometers per hour in still water. Find the speed of the boat with the stream, that is downstream, if the current of the stream is 2 kilometers per hour. Now, excuse me, now with the stream or downstream speed is equal to still water speed plus current. What is still water speed here? It is 10 kilometers per hour plus the current is 2 kilometers. So it's 12 kilometers per hour. Now the question number 4, we got the downstream speed or with the stream speed as 12 kilometers per hour using this formula. Now we can also get this answer by using these two equations. This equation from question number 2 and equation from question number 1. substituting in these equations the values that are given in question number 4, we can form these as two simultaneous equations, solve these simultaneous equations, and then get the downstream speed. Or you can directly use this formula, whichever is appealing to you. Okay. Now, coming to the 5th question. Now, question number 5 is, if a man can row a boat at 18 kilometers per hour in still water, and he can row twice speed in downstream than upstream, then what will be the speed of the stream? Now, to answer this question, again, I would request you to use the formula given in question number 1 and 2, okay, with the values that are given, and use that to find the answer. Once you do that, you will get the question as you will get the answer as 6 kilometers per hour, or you can follow the explanation that is given here, right? Now, question number 6 is also along the same lines. If a man can row a boat at 18 kilometers per hour in still water, and he can row thrice speed in downstream than in upstream, what will be the speed of the stream or the current of the stream? So again, I urge you to either follow this explanation or use the formulae given in question number 1 and 2 and solve the question. You will find that the answer will be equal to 9 kilometers per hour. That is the current of the stream or the speed of the stream. Okay. Now, coming to question number 7. A man can row a boat to a certain distance upstream in 4 hours and take 3 hours to row downstream the same distance. Alright. What is the speed of the boat in still water if the speed of the stream, that is the current of the stream, is 2 kilometers per hour? Okay. Now, questions 7 and 8 are similar. Okay, here we are asked to find, in question 7, we are asked to find the speed in still water given this data. So the formula for that is very simple. We take the speed of the stream, that is S, or the current of the stream, multiply it by the time taken upstream plus the time taken downstream to travel the same distance, divided by the time taken to travel upstream minus the time taken to travel downstream, which is equal to 2, which is the speed of the stream, the current of the stream, multiplied by 4 plus 3, 4 hours upstream and 3 hours downstream, divided by 4 minus 3, which is 2 times 7 divided by 1, which is 14 kilometers per hour. Question 8 is also similar. You just have to rearrange it. Okay. See, a man can row a boat to a certain distance upstream in 4 hours and take 3 hours to row downstream the same distance, same as this question. But the question here is, what is the speed of the stream if the speed in still water is 14 kilometers per hour? So speed of the stream means the current of the stream. Okay. Here we were given the speed of the stream. We were asked to find the speed of the boat in still water. But here we are given the speed in still water and we are asked to find the speed of the stream. So same formula, rearrange it and substitute the values to get an answer of 2 kilometers per hour as the current of the stream. Okay, so S would be the speed of the boat in still water, which is 14 kilometers per hour, multiplied by time taken upstream minus time taken downstream, divided by time taken upstream plus time taken downstream, which is 14 times 4 minus 3 divided by 4 plus 3, which is 14 divided by 7, or 2 kilometers per hour. This formula is the same as this formula, only thing it is rearranged. Okay, so start with this formula and rearrange it for yourself. You will get this answer, right? Now, moving on to number 9. A man can row a boat at 6 kilometers per hour in still water and the speed of the current is 2 kilometers per hour. If he takes 45 minutes to row the boat to a place and back, find the distance between the two places. Okay, for this we have a formula. So we have to find the distance. The distance is equal to the time in hours, that is big T, multiplied by a square minus b square divided by 2a. A is the speed of the boat in still water and b is the speed of the current. So once you substitute it, you will get, we have been given the time in 45 minutes. So how do you convert minutes to hours? You divide it by 60, correct? So 45 divided by 60 multiplied by a plus b times a minus b. Also, this can also be written as a square minus b square divided by 2a, which is equal to 6 plus 2 times 6 minus 2 divided by 2 times 6. So that is 45 divided by 60 into 8 times 4 divided by 12, which is equal to, when you simplify, it becomes 3 divided by 4 into 2 times 4 divided by 3, which is equal to 2 kilometers per hour. So this formula you will have to memorize and then solve the questions accordingly. Now, coming to the last question. A man starts at 6 a.m. from A to B at 40 kilometers per hour. Another man starts at 7 a.m. from the same point A to B at 50 kilometers per hour. At what time will they meet each other, or at what time will they cross each other? For such questions, we have to follow this formula. S1 times S2. S1 is the speed of the first man times the speed of the second man divided by speed of the second man minus speed of the first man into the time difference between them. So it's 40 times 50 excuse me, divided by 50 minus 40 into 1, which is 200 kilometers is the distance. When you divide that by the speed of the second man, you get a time, right? You add that time, which is 4 hours here, to the starting time of the second man to get the time at which they will cross. Why do you take the time of starting of the second man? Because we are dividing that distance that we calculated here, 200 kilometers, by the speed of the second man, okay? And we get the time of crossing as 11 a.m. You'll have to learn this formula for this question. There is no other way out. I hope you found this video helpful. Please put your comments in the comment section of our video in order to so that we can help you understand better. Wish you all the best and please keep practicing. Thank you.